I should compliment Kudoka and the chemistry department for starting this series called Eminent Alumni Lecture Series. But I feel the department is so eminent that any other alumnus would have quite fitted into giving today's talk. Therefore, I feel privileged to deliver the opening lecture. Special thanks to the organizers for it. I should also compliment you for choosing today's topic, which is so relevant and so contemporary. So I think I can go to my presentation right away. Okay. So as you can see in the screen, the subject is so vast, so contemporary that I don't have the expertise to talk about everything. Instead, I will give you an overview of global warming and what are the different strategies to combat it. There is no subject on Earth which is discussed and debated more than global warming and climate change right now. A subject to which all human beings, animals, and plants have contributed. And a subject for which combating it, all this, everything on Earth have to contribute. A subject in which every learned person has some opinion or other. Therefore, I have taken a great risk of choosing a subject which is known to every guy, because there could be always some difference of opinion and things like that. Therefore, I would like to get a feedback from all of, at least from some of you, or possibly all of you, because every one of you is a specialist in one aspect or other. So let us go to why we have to combat global warming. The answer is given by none other than Stephen Hawking, who in 2006 wrote that man will have to find a place elsewhere in the universe because of the disasters that will destroy the Earth. He has classified topmost among them three: sudden global warming, nuclear war, or a genetically engineered virus. Why he said so? Because in his own lifetime, he has seen the first two events. European summer in 2003 killed 50,000 people, unimaginably such large number, because the temperature went to 40 degrees, which was unheard of in the Europe at that time, and therefore, especially the elderly were not prepared for that. He has also been, at least in his younger days, heard about Hiroshima and Nagasaki atomic bombing, in which on the respective days of bombing, about 1.2 lakh people died, and another 1 lakh died, and then the end of that. He had the wisdom to forecast that, let us hope that this is not a genetically engineered virus. He had the forecast say that a genetically engineered virus can kill the whole humanity. Today, as of the 1st of November, 5 million people have died from Earth. Global warming, it is so much higher, projected. Something like 600 million people, 7.5% of the entire world population will perish if things continue like this. So obviously, global warming is a disaster that can destroy the Earth, and therefore, all the nations were thinking about it for several years together. And finally, in the Paris Climate Conference, that was the 20th in a row, 21st in a row, on 30th November to 12th December, after 20 years of hard negotiations, an agreement was drafted. India ratified the Paris Climate Agreement on 2nd October 2016. The Hindu reported on 3rd November that the estimated cost of India's climate action plan is $2.5 trillion US. 2.5 trillion US dollar is so huge an amount that I cannot imagine, or neither, I don't think anyone of you can imagine the magnitude of the cost involved. Therefore, I have given a picture, a statement that it costs 1,40,000 rupee for every Indian, including the newborn. So you can imagine what is the terrific cost involved in that plan. But there were very little discussion. I have not seen any discussion, serious discussion in the parliament or heard of what are the action plan. Or there is no awareness of the action plan, except some sort of everyday discussion going on in the television sets. But the situation has changed now, because Kerala, which once upon a time contemplated very proudly that we are an air-conditioned town, air-conditioned state, no problem with us. But the temperature at several parts of Kerala has gone to 42 degrees. And in year before last, there were 3 deaths due to sunstroke itself. Followed by 2018 floods, 2019 landslide. At that time, our leaders said that, oh, this will happen once in 100 years, don't worry. But then it repeated in 2021 also. Not only in India, but from Kerala to Kashmir, it has happened everywhere. This is a Kashmir flood. It is not confined to Kerala and India. You know, the Siberian temperature, Siberia is a place where it is the lowest temperature around the year. The temperature recorded June last year was 38 degrees centigrade, unprecedented, which was followed by severe floods in the west. This is Belgium, this is Germany, this is China. It is stated that this is the heaviest rain in 1,000 years. This is USA. So now at least there is an acceptance that global warming is a problem and it leads to climate change and calamities. This was reinforced by the 2021 Nobel Prize for these 2 gentlemen, Manabe and Heiselman, for physical modeling of Earth's climate, quantifying variability and reliably predicting global warming. Thus, you can see that global warming and climate change is a very complex, multidisciplinary subject. As I said earlier, I'm not a climatologist, neither a very enthusiastic, environmentalist. But why I ventured to this program or this area of, and it was nowhere in my curriculum or interest till 2012, when we had a PhD program in IIST with Dr. Deepthi Sivadas as our PhD student. She successfully completed. Dr. Rajiv and Prabhakaran were the co-supervisors. So since then I have developed an interest. I tried to consolidate and analyze the available literature on global warming. I want to tell you that I am not going to tell our research work here in any great detail, because it has to be a common awareness program. I wish there were hundreds listening today, because this is the most contemporary, most relevant subject today. But probably every one of you know. Okay. But then when I pursued literature, I had some doubts which I would like to share with you. For example, American President Obama spearheaded the Paris Agreement. Trump pulled out of that by telling that this is an expensive hoax created and for Chinese in order to make US manufacturing a non-competitive. And then when Biden came, he pitched it. So this gives a doubt not only in me, but in many, many people. Is global warming only a political game like UDF, LDF? One fellow follows one policy, the next fellow pushes it out, and therefore the policy by itself is not relevant. Or another doubt is that, the oil lobby, who have got an annual sale of 2.1 trillion US dollars every year, they say that global warming is due to fluorocarbons having 10,000 times more warming potential than the emissions from fossil fuel burning. They are true, but they suppressed one important fact that the fluorocarbon emission is only 52,000 tons in a year, whereas from 10 billion tons of metric tons of fossil fuel, the CO2 emission is 37 billion tons. So even if you multiply this by 10,000 and then divide by this, it will be about 1.5% only. So the second doubt is there any hidden agenda behind the information given? Or there was a very interesting thing before the Paris Agreement, even today people are talking about it, carbon credit trading to control global warming. That means the rich countries who emit more will buy carbon credit. One carbon credit means 1 ton of carbon dioxide is equal to some amount that was say $20 or $100 or whatever it is there. So, but then the big question comes, as we will see later. Today there is 22 billion ton of excess carbon dioxide being emitted to the atmosphere. So is it for sinking the excess carbon dioxide emitted, or is it for the profit of the traders? Because the anticipated trade is something like $400 billion US. This was in fact opposed by those countries itself. And then coming to our own state, on 8th November 2016, we have rolled out the first CNG bus in India, and very proudly it was flagged off by various people. But we don't see, neither I nor you see any CNG bus in the road. Is it because it was an unviable proposition? And therefore, is it not true that any action taken has definitely a viability as one of the criterion? Or we teach our students, our youngsters, kindergarten up, plant a tree and save the planet. The question is, today you imagine that from the newborn on, we plant 1 tree each. So 7.9 billion trees are planted. Are they adequate to combat global warming? These and some of the more questions I tried to answer in a scientific manner by answering 3 questions of what. What is global warming? Is it a myth or a reality? What is the impact of global warming on climate and ecosystem of the Earth, present and projected? And what are the remedial actions? For finding out the remedial action, first we should know what are the reasons for global warming and how to prevent and reduce global warming. So this is a huge challenge because the remedies have to be found out at affordable cost without hindering human progress, and therefore there are tremendous opportunities for the next generation people to work out such remedial actions. Okay, let us go to the first question. Is global warming a reality or a myth? The advocates say that the past 10 years, no doubt, nobody disputes that, are the warmest decade on record. Or 2020 is the warmest year on record, not only warmest year, it's 40th consecutive year above the average temperature. But then the critics say that, okay, fair enough, there are warm summers, but then equally cool winters. President Donald Trump himself, in one of his speeches, that it is freezing in New York. Where the hell is global warming? So as a scientist, what we do, we have a rational approach of taking the global mean temperature and average over the entire surface of the planet during the entire year, for which there are 11,000 weather stations around the globe and also dozens of satellites continuously monitoring this, upon which we get a temperature profile of the Earth like this. All these are above the average value. So you can see that the entire Earth is only a few places are slightly below the average value. So from this, we can plot the global mean temperature. These are individual data. This is 5-year mean smoothing has been done, statistical method of doing it. That is taken related, as you know, a small change is, if you plot as a delta t, that will be better depicted than absolute t itself. So this is plotted as a delta t based on taking 1950 to 1980, which was somewhat stable temperature as the reference point. So this is a profile from 1880 to 2000. So the annual mean temperature was 14 degree at this point, but today it is 15 or 15.1 degree now. So global warming is a reality. Even Donald Trump later on said that I don't think it's a hoax, but I do think that there is a difference. But I don't know whether it is man-made or not. Whether it is natural or man-made, we will try to answer not only, our president, but all others who are having the doubts also. So if we look at the temperature profile during the last 1,500 years, starting from 500 AD to AD 2010, 2020 AD, this is the temperature profile. So you look at this, this is the sudden warming as our scientist Stephen Hawking has warned us. Today, the rise is 0.25 degree per decade. Okay, so many people ask, why you are concerned if there is a small change after 1 degree only in the global mean temperature? The answer is to find out, is there any correlation between natural disaster and global mean temperature? In fact, this gives you the number of natural disasters above a certain criticality classified into 4 categories: geophysical events, that is like earthquake, tsunami; meteorological events, that is like storms; and then hydrological events like flood and mass movement, that is landslides; and then climatological event, that is extreme temperature, drought, and forest fire. So a better picture, this gives an idea that it increases, but a better picture comes if we can plot with a reference to 100% taken as this 1980 point. So you look at this except geophysical event. Geophysical event, because it happens of certain events under the surface of the earth and therefore nothing to do with the external temperature. All other events show an increasing trend. The maximum being flood and landslide in particular. You can ask, okay, I can understand if temperature increases, there can be more warming, there can be drought and then heat wave, but then how heavy rain and flood? The answer is obvious to chemists and scientists, because the higher the temperature, higher is the amount of the water in the atmosphere. For example, this is the saturated vapor pressure versus temperature curve. For example, from 14 degree taken as a reference, there will be 6% increase in the vapor content at 1 degree increase in temperature. Or if it is 4 degree, there will be 29% increase in the vapor content, saturated vapor content. And therefore, when water condenses as rainfall, there will be heavy rain. In fact, there are heavy rains and floods continuously after the year 2000. Kerala flood is the most typical example. There was a rain of 320 millimeters in 1 day, and 483 deaths were there, which was accelerated by the way the dams were also opened. You know that. In Mumbai, there was a rain of 944 millimeters on 1 day, and the death on that and next day was 1,000. So that is the indirect effect. Now let us see what are the direct effects: heat wave, drought, and forest fire. The death toll due to heat wave in India since 1971 is 17,000. But this is said to be underreported because, like your corona death or COVID-19 death, people say it is underreported. The reason is that suppose somebody dies in the street, whether it is exactly due to heat wave or not, it is very difficult to say. But even that reported crosses 70,000. Then there is a drought. 15 million people have been affected. 55 million people are affected globally every year by drought, according to World Health Organization report. This type of pictures you see, this picture is a rare one, which you would have also seen. In the whole district of Marathwada, there was only one well having water. So by 2015, half the world population will be living in water-stressed area. So forest fire due to hot and dry weather. All of you, even children, know that Australian bushfire in 2020 killing 1 billion animals, 34 people, and 5 billion loss. The worst among the whole thing was a Russian wildfire in 2010, where 56,000 people died, and there was a 15 billion damage was there. And it took almost, if I remember correctly, 5 to 6 months to extinguish that forest fire. Yet another important aspect of the global warming is the increasing sea level. That is because of the decrease in density of the warmer water and also melting of ice. You know, this was projected once, and this is a truly measured one. Those of you, I came to Trivandrum some 60 years, 65 years ago. Our beach in Changamugam was almost half a kilometer away, but today it has eroded into our road to the airport also. So melting of ice, already 500 billion ton of Arctic ice has melted, and there's a reduction in the ice coverage of sea by 1 million square kilometers. And our satellite picture very clearly shows 20% reduction in the Himalayan glaciers. And then this type of a picture is available in your calendar, so I don't explain that further. But there is a projection. Suppose things go like this, there could be 4-degree rise by 2100, and the sea level can be, average sea level can be about 1 meter high. So what will happen is many places will disappear from the world map, and millions will get displaced or perished. For example, port cities like Mumbai, Calcutta, and Cochin will not be there in the map. From Colaba to Thane, everything will disappear. This is a condition of gateway of India today, but at that time, if things go to 4 degrees Celsius, this is a simulated condition at that time. Not only coastal cities, but the entire islands like Mali, Andaman, Lakshadweep. These are our neighbors, and many other around the globe will survive. But you may say, oh, I am not living in a coastal area, so why worry? Look at our Kerala. In Kerala, a part of Kerala indicated here will also disappear from, that is starting from, let me tell you, Arattapuzha to Vaikam. Arattapuzha in Chengannur region to Vaikam in Kottayam district will submerge under water. Even places like London, there is a prestige of London, Westminster Bridge is like this, but that bridge will be underwater, and if this tower will be 1/3 underwater. So adaptation and man animals to such changes in climate is doubtful. 10% of the species existing prior to 18th century have already disappeared. So how do we prevent that? That is the next part of the lecture. First step to prevent is to understand or reduce the disaster, mitigation. Understand the root cause. Without knowing the root cause, you cannot prevent the calamity. So global warming is caused by 3 changes in the radiation balance of the Earth. One is change in incoming solar radiation due to changes in orbit of Earth around the Sun. This is a natural phenomenon. Changes in fraction of solar radiation that does not reach Earth, it gets reflected or absorbed by aerosols. Natural, like, you know, what comes out of underneath the Earth, and human means what come our burnings. Changes in absorption of natural of radiated heat by atmospheric by the absorption due to atmospheric greenhouse gases. This is natural as well as human-made also is there. But this is a gross phenomenon. Local climatic changes depend on how this heat is distributed by wind and ocean currents, etc. That's why this year it may be heavy rain in Kerala, next year it may be somewhere else. But overall the rain is higher. That's what it means. Okay, so let us try to understand what is meant by changes in incoming solar radiation. There is what is called Milankovitch cycle. That means there is a regular variation in the eccentricity or the orbit of Earth around the Sun, this being the minimum and that being the maximum. But then this takes about 100,000 years. That means 1 lakh years from this to go. Or there is a change in the tilt of the Earth on this side to the other side, and it takes about 41,000 years to happen from one end to other. Correspondingly, there is a precessional change of the spinning that takes about 24,000 years to change. Therefore, the net effect in the global mean temperature which is the reason for the prehistoric ice age. This is the temperature. Of course, nobody could have measured at that time. It is from the isotope ratio as well as of samples collected from ice core as well as tree ring width of fossil trees. So the globe underwent 8 cooling cycle, 8 glacial cycles where the temperature went to almost 8 degrees below our current level. But then look at therefore the rate of change was only 0.008 degree per year, much lower than the present global warming. Present global warming, as you have seen, is 0.25 per 10 degree, and therefore the global warming cannot be due to change in incoming solar radiation. Another one is variation in energy output from the sun. Sun has got a 11-year solar cycle, where, the flares come and then the intensity increase and then diminishes. But this is a cyclic variation, but the global warming is a continuous variation. Then changes in aerosol, because below 10 micron, they take above the cloud, they take several years to settle down. There are two effects. One is the cooling, other one is the heating effect. Cooling effect due to tropospheric, that means up to 12 kilometers. They seed the clouds, which give a shielding to the earth, and the stratospheric region where the volcanic eruptions give rise to mainly sulfated ash, which are white in color, and therefore they reflect the sun, and therefore that leads to cooling. On the other hand, today many the so-called atmospheric physicists, they say that global warming is due to carbon black rather than due to gases, because as heat from combustion, they can absorb radiation and therefore they can warm the earth. They attribute it to increased air traffic. But let us, very unbiased way, let us look at what is the net effect. So aerosol cooling, cloud cooling is on this side and the black carbon soot in the other side. So net, even today, even in 2021, net effect is cooling. However, with increased air traffic, this can go to this side in years to come. Okay, but the next is change in heat radiation being absorbed by atmospheric greenhouse gas. 1820, a famous mathematician, Fourier, calculated the global mean temperature as -18 from the sun surface temperature and the distance. Even today, that figure is undisputed, but the measured value is 14. So where does that extra 32 degree come from? He simply postulated that this is due to some sort of a greenhouse effect of the atmosphere. But what is the greenhouse was again discovered by one of our famous chemists. Of course, physicists say that Arrhenius was a physicist also, so I don't quarrel with them. Whatever is there, Arrhenius in 1869. He said that the sun will heat up the earth and the heat will get irradiated as infrared radiation in these regions beyond the normal solar spectrum. Majority of it will go away and a part of it will get absorbed by gases like carbon dioxide, and the higher the carbon dioxide concentration, higher is the increased temperature. But this, later on it was found that atmospheric carbon dioxide alone cannot account for the 32 degree increase in temperature. That should account only for about 2 to 3 degree rise in temperature. Then what is the other thing? The greenhouse gases that keep Earth warm to sustain life is water, carbon dioxide, methane, nitrous oxide, and fluorocarbons mainly. Water is the largest contributor, 90%. But then you can ask why water is not considered as a greenhouse gas leading to global warming. That is because water is a condensable gas with a short atmospheric life of about 10 days, and it will condense. Therefore, it does not lead to continuous increase in temperature. Had carbon dioxide condensed like that, it would also not have led to continuous increase in the global mean temperature. So the global mean temperature increases because of the non-condensable gases, and these are the main ones. Their lifetime, average lifetime in the atmosphere, and also atmospheric concentration in absolute term, and their global warming potential. That means how much by the infrared absorpance value. So how much in relation to carbon dioxide. This is for methane, nitrous oxide, and this is for CFC. The oil mafia, I mean, not mafia, the people said was correct. But then look at the concentration, it is only 6,000 part per trillion, or 0.0006 ppb. This is the concentration. So today, the change in greenhouse gas concentration from 75 to 2005, carbon, this is in ppm, this is in ppb, this is in ppb, this is in ppt. This was continuously increasing. Nitrous oxide is also continuously increasing, but in ppb, in the case of CFCs, they showed a dip because of some of them were banned like CFCs, but then other fluorocarbons have taken over, and therefore it is also increasing. So today we have tools available, thanks to our Nobel laureates and others who worked in this field, to exactly delineate what is due to natural factors and what is due to various factors like this. Had it been purely natural, as our Trump said, it should have been like this. It is a good tally between observed and simulated one is due to the superimposition of the man-made factors. So if you quantitatively say the solar, as we said earlier, due to the orbital change, etc., is less than, this is cumulative effect from 1880 to 2019, less than 0.001 degree, aerosols still minus, natural variability like El Nino, it is plus minus, and man-made greenhouse gas, it is 1%. So the relative amount of global warming gases, and they are normalized to, not the absolute amount, they are normalized to their warming potential. Taking carbon dioxide as the standard, it is like this: carbon dioxide 76, methane 16, nitrous oxide 6%, and the fluorocarbons and other gases 2%. Methane essentially comes from, as you know, from rice paddles or wetland or from cow dung, and also from this where coal is excavated. It is methane is a gas coming, and methane has got a relatively shorter life on the atmosphere because it gets converted to carbon dioxide. On the other hand, nitrous oxide has got much larger lifetime, but it is majority of it is due to agriculture and also the manure which is being used, and therefore nothing much can be done. So we instead concentrate more on carbon dioxide because that contributes to 76%, and its share is continuously on the increase. This shows the increase of all these 6 gases in from 1880 to 2020. This is increase, but the relative increase is more for carbon dioxide, and if one is taken as 1990 global warming, it is 41% more than that. Okay, clear, I suppose so. Okay, shall we move on? Okay, so our discussion will have carbon dioxide as our main greenhouse gases. Why I am taking a Bail is that later on don't say, oh, why you didn't say about nitrous oxide and methane? They also warm in a similar way. That is what I want to tell you. Now let us look at the carbon cycle of Earth. This is a very important slide. Look at it very carefully, which shows that 770 billion ton of carbon dioxide, which is 95% of the carbon dioxide going to atmosphere by decomposition and respiration of land and aquatic biomass, is due to the natural source because of this. And only 5% is the human source. So out of the total 810 billion ton of carbon dioxide, this is the proportionality. That is much better shown here. The both microbial respiration as well as plant respiration and the fossil fuel burning together gives out 440 billion ton. And then what the land emits is 440, and fortunately, thank God, the land can got the capacity to absorb 440 billion ton also by the various photosynthesis materials available on the land biomass. And it has got a reserve for another 11 billion ton, which goes into soil. The ocean, you may be surprised to know that the ocean has got what is called phytoplanktons, which are, ocean is a great forest, no? But only thing is that forest plant is very micro. You can see it only under microscopes. Like the phytoplanktons, they also emit carbon dioxide from dissolved carbon dioxide as well as by this plant material. 330 it emit, but it has got capacity to sequester, permanently absorb and convert it into carbon mass. 330 and another 7 billion ton capability is there. But unfortunately, today, anthropogenic, that means what is human source, is 40 billion ton. Out of that, only 7 plus 11, 18 billion ton, the earth has got the capacity. That means 22 billion ton gets added on to the atmosphere. 22 billion ton in the atmospheric mass is 5.2 into 10 raised to 6 billion ton of air. So that means this divided by that, other will give you 42 ppm increase in carbon dioxide in 2019. And then this will, any iota of carbon dioxide now emitted is extra above the sequestration capacity of Earth, and therefore it goes into atmosphere. Why I said this? Is it my own imagination? It is not so, because for thousands of years, the anthropogenic carbon dioxide was within the sequestration capacity of Earth at about 280 ppm. This was found out by excavating samples from deep underneath our ice, and then because a sample will be intact there and aged by carbon dating and condemned by mass spectroscopy and other techniques. But then there is a sudden increase, that tallies with industrial revolution, because after the industrial revolution, there has been copious evolution of carbon dioxide and other greenhouse gases, and it has gone to 410 ppm right now. So post-industrial increase in carbon dioxide is the primary cause for global warming. There is a very good tally between the increase in temperature and also the increase in carbon dioxide concentration. So if you look at the carbon dioxide concentration measured in a similar fashion, from 400,000 years back to today, it was cycling like this only, but now it's steeply increased after the Industrial Revolution, and therefore this is what Stephen Hawking was worried about, the sudden global warming. So let us see what are the sources for anthropogenic carbon dioxide. It is a rapid industrialization and growth in transport sector. Both use fossil. Am I audible because of the rain background? Otherwise, I will put on my.
Yes, sir. You're quite audible.
Okay.
No issue.
Because there is a heavy sound due to the rain here.
Okay.
So there is a solid fuel, coal, liquid fuel, and gaseous fuel like this. So the combined emission is 33 billion ton, because as you know, chemists do not need an explanation. 1 ton of coal can give you 3.5 ton of carbon dioxide, and 1 ton of petroleum product can give you 3.1 ton of the carbon dioxide. To add fuel to the fire, now there is a deforestation going on for years together. 20 million hectares of forest, equivalent to 5 times the area of Kerala, is lost every year. So that is both in tropical, this is tropical, and also non-tropical forest. This is how the forest destruction has been going on. So that is equivalent to another 7 billion ton of carbon dioxide added from the reduction in photosynthesis as well as the forest fire. Yesterday, I added this slide yesterday evening, because by listening to one of the learned man in yesterday's TV anchoring, there he said that we have not reduced any forest forest has increased because whatever forest is destroyed, there is a plantation which has come up. So you may also think, is it not so? But then look at the carbon storage capacity of forest, plantation, and carbon crop. This is a gross average. So clearing forest and then replacing it with plantation is not a true substitution. That's what I want to tell you. So how do we find a solution? Because these are all essential activities. So the world has been, this is a very interesting graph, some of you would have seen. World has been debating for several years. How do we do that? This histogram shows you, actually, this is the per capita emission versus population. This is therefore the integral of this population into per capita will give you the country's emission. So if you look, India is very low here, but when you take the integral, India becomes the third place in the run. China is the first one, USA second, and so on. So when you point out this to India and others, they will say, no, this is not the criteria. Let us look at the per capita. So this is a per capita. US is 15 tons per annum. India is very low, only 1/5, like 1.5 ton per annum. If you look at the cumulative carbon dioxide emission all these years, starting from 1880 onwards, then US is first, China second, and in India and France, it is like this. So people have been debating, years of discussion. Who is responsible? You do it, you are responsible, But finally, the world could come to a comprehensive agreement in the 21st conference, because they said, rather than somebody else telling you do it, they said, you say what you can do. Okay, incidentally, this is the best method of challenging our students also. You yourself fix your target and work for that. That is what they did. So the UN decided, this climate conference decided to limit the global mean temperature to 2 degrees. But now they have come down to 1.5. Why, that I'll come to later on. To prepare and publish one's own nationally determined contributions for reducing greenhouse gases, reflecting your own possible ambitions, and then review and report regularly the progress made and then you don't keep it in your mind, but report to us, and then submit your improvements every 5 years, and it should have some incremental progress compared to the 5 years. And also another decision taken is developed nations will provide $100 billion annually to developing countries to combat global. But I don't know where they have given. At least our country says that we have not received any big part of the $100 billion. So the deal is set as the deal sets the goal of a carbon neutral world. Carbon neutral means whatever is emitted, the Earth will have capability through various means to sequester the whole of it by 2100 AD, or preferably 2050. So as you know, in November 2021, India took a very responsible stand. I volunteer to say that in the 26th COP, that we will become carbon neutral by 2070. Now, when the PM makes such a statement, it is your responsibility and my responsibility to strive for that. So let us see how to do that. But then, why that 1.5? Because globe was becoming warmer than anticipated. Any simple calculation which I did showed so, because the current level is 3.5 tons per year. 4.35 tons per year. You have seen that, that graph from that. This is the value. So 22, as we will see later, 22 billion ton of non-sequestrable carbon dioxide you have seen earlier, 22 billion ton, is coming out every year. Now you imagine that no further increase in carbon dioxide emission, we will keep that 22 billion ton constant. So cumulative effect of that till 2020 will make atmospheric carbon dioxide concentration to 750 ppm, and corresponding global mean temperature is 3.3. But then people are not going to remain stagnant. They will try to develop themselves. And if you imagine that by 2100, half the globe will acquire the standard of USA by 2100, then they will have 50% of USA emission. Then the average emission will be 7.5 tons per annum till 2001, and then the carbon dioxide concentration will be close to 1000 ppm, and the temperature will be 4.5 degrees. So what a tremendous change you have seen. That is what the UN chart a couple of years showed us, that if you don't take any action, it will go to 4.5. If you take current NCD, still it will go to 3.5. So if you want to go to 2 degrees, this is the current level is about 40 billion ton of carbon dioxide. We have to go below that. Even if you are not carbon neutral, you have to go below that. To go to 1.5 degree, you have to go still further down, which is a very challenging task. But India has accepted this huge challenge. Accepting this huge challenge means we have to find out resources and appropriate methods to combat global warming while providing quality of life to the poor, life of millions of the poor. We cannot say, okay, I have a car, therefore let nobody else will have. See, when I was a young child, there were only 3 cars in Tiruvalla. So those 3 car fellows would have said at that time, when the 4th car comes, what is these guys are bringing in pollution to our camp? So that we cannot do as a country. We have to provide quality to millions of poor. But how do we do that? To provide achievement by shifting from the beaten track of fossil fuels to newer, non-polluting renewable energy. What I said is quite clear now. If you see at the electricity generated in 2020, this is the total in terawatt hour, and this is by India, China, and USA. This is per capita units. This is world over, and we are only 1/3 of the world average. In fact, electricity consumption is an indirect indication of the advancement of a country. We are only 1/10. We are much lower than United States and China. So is our emission also. At the same time, look out, a new index has come out, what is called CCPI, that means Climate Change Performance Index. We now happily or proudly say that we have got a 10th position, much above China and USA. But our pride can come really true if we can go high in this area also. So how do we do that? So we should have strategy for mitigation of global warming. So next half an hour, I will spend on that. That is removal of, how can we do that? Well, first is remove the carbon dioxide, add no more carbon dioxide, and then third, how do we remove that? Increase the sequestration capacity of Earth. That is, increase the biomass on the land and in the ocean, because we have seen earlier that ocean has got a large amount of green biomass that can remove carbon dioxide by photosynthesis, or decrease the greenhouse gas emissions, mainly carbon dioxide, to the atmosphere in energy generation, transport, manufacturing, and solid waste management, because these are the 3 main areas of emission on the globe right now. Or can we have some solar radiation management and climate engineering into the thing? We will take one by one. Okay, removal of carbon dioxide from atmosphere. How do we do that? You reforest. That means whatever forest you have cut, plant tree, and then bring the forest back to the original position. Or afforest. Afforest means wherever there was no forest was there, like in deserts, like in UAE, they have done a wonderful job. Those who have gone there, they have seen it themselves. They have created new forest lands in the desert. Why? Because a tree on an average, remember it's an average, teak tree can give about 3 times this. So, but we are not going to plant teak tree alone. A forest is not teak tree alone. On an average, a tree can sequester 22 kilogram of carbon dioxide per year for photosynthesis. This is net of what it absorbs and what it gives out, and it gets it converted as the solid wood. That is 22 kilogram per year per tree. In addition, tree reduce temperature by blocking the sunlight. No explanation needed for this. Further cooling occurs when water vaporizes from the leaf surface area. Cooling of a big tree like our banyan tree, that is why people go under that and rest, is equal to 10 room air conditioners. So we have found the solution. So why worry? Trees are the best weapons to combat global warming and maintain the carbon cycle. So where is the issue? Where is the problem? The problem is this. However, trees are inadequate for the present and projected emission of carbon dioxide. Let us examine. Let us see whether I am telling a truth or not. Every of my statement, you must imagine in your mind whether he is trying to sell like the oil lobby. Oh, not oil lobby. Oil lobby, some idea or not. I don't. Unfortunately or fortunately, I don't have any lobby attached to me. Okay, the annual emission beyond the sequestration capacity. You remember the carbon cycle picture I have shown you? 22 billion tons beyond the Earth sequestration capacity. 22, fortunately the number tally, 22 kilogram per annum is the capacity of a tree. So if you divide 22 billion by 22 billion ton by 22 kilogram, the result is 1 trillion additional trees are needed. So my dear friends, this is what I am trying to tell you. 128 new trees per person are needed if we want to sequester entire additional carbon dioxide which is given out by the mankind. Where is the land to plant 128 trees per person? Not only that, even if you find the land, trees need years for full growth, while emissions will go on increasing. This is a nice picture. I suppose the children or our students will enjoy, or elders can also enjoy. I myself enjoyed this picture, so you will enjoy. You know, this is Shah Rukh Khan. I don't know who is this lady or what was this picture. Later on, you can answer me. She was pulled into the train by Shah Rukh Khan because the train was a very slow-moving train. They would have made it still even slower for the purpose of taking the movie. Suppose he was in a bullet train. The poor lady would have been left behind. So that is what is happening today. As the tree grows, even if you find a place, the emission will be going on increasing further and further. So the only way is, along with planting the tree, we have to slow down the greenhouse emission. So that is what we are going to see. How to do that? Improve the sequestration capacity of the Earth. How can we improve the sequestration capacity of the Earth? One proposition is to have what is called a biochar. It is produced by pyrolysis of biomass in absence of air to generate extremely porous char that can absorb carbon dioxide and retain it for several years and then put it underground like this. Our research was also output like this. So carbon dioxide from crew cabin, removal from crew cabin in the manned space mission was our PhD program. And then is Deepthian team or our team, they have made beta cyclohydrogen complex as the lithium hydroxide. This is now chosen for our manned mission, and therefore this is also made deputy project director for our Indian manned mission project. But then we thought that we should not only do this, but we should do something for humanity. So if this comes up later on, they will all remember us in time to come. So we have made a synthetic biochar, which is much more capable than what is available today through this route, and it was published in the journal Carbon also. But I would like to caution you that we have done only in gram level in our laboratory. What is its production cost, it is viable, etc. We have not done because it is much beyond the scope of a normal PhD thesis. Okay, that is the land. Then why not look at the sea? and improve the sequestration capacity. You know, phytoplankton growth can be improved by iron fertilization. So spray iron, not in large quantity, but in ppm ranges on C, or make the surface water more nutrient by bringing up the deep ocean water, which is having lot of manure in that, bring it up so that it will improve the growth of the phytoplanktons, and therefore it will sequester more carbon dioxide. But C is no man's property. So it's a good in paper, but nobody is willing to do. So let us look at reducing anthropogenic. See, it's always like this. If income tax is cut from your salary, you don't mind. But when you are asked to pay later on, people will scratch their head like that. We will try to see how to reduce the emission where we make it. So that may be more facile than asking somebody to go to the tree, go to the ocean and spray manure there. So let us look at the progression of carbon dioxide emission sources. These are source-wise, it is classified into the year. This is a planned land usage which you have seen earlier, that is cutting the tree and things like that. This is coal. In 80s, there was only coal, and it has gone up. Then came in, this oil, which has gone up, and then gas and other sources like CFC, fluorocarbon, etc. This is the source of carbon dioxide emissions today. So if you, from the source, if you go to the sectors, which are the sectors? If knowing the source is good enough, but where do they use this is very important. Where do they use this is very important. So let us take the sectors which use this maximum. The largest CO2 emitting sectors are electricity grid, transportation, followed by industry. Others are 16 small percentage, so we will leave it, because if you take each one, then we have to have separate sessions for that, So let us go to electricity generation. Today, electricity generation in the world, you see that 65% is thermal, 10% nuclear, and 25% is a renewable energy. In that itself, coal is more. If you take the Indian scenario, I think it is 66% is again, again coal-based, mostly coal-based. And then we have hydro about 14%, and then nuclear about 2%. If you take India, we can, Kerala, we can say very proudly that our 72% is hydro. However, in the energy scenario, Kerala is such a small, minuscule that, okay, whatever you are doing okay, but then it is, we are not adding like others to the global warming gases. Okay. So this is a very interesting slide. I request your attention. This tells us the whole thing about electricity generation and CO2 emission. This shows you CO2 emitted grams of CO2 per kilowatt hour. That means per unit electricity generated. Almost 900 grams from coal, 700 grams from oil fired, CNG, compressed natural gas, this thing. Combined cycle of that, all these things have carbon dioxide emission. But then look at solar, wind, nuclear, geothermal. Geothermal means there is very little scope, and hydroelectric. By itself, it does not produce any carbon dioxide. This is from the machinery and other things which are used for that purpose. But then nuclear energy is one of the very good examples. But today, widespread unacceptability is there because of the Chernobyl blast and Fukushima not blast, leak and disasters. So today people will strike against that. Our Ani, I think Ani is, you are from somewhere in Kanyakumari district, no? There are people did satyagraha for 1 year to prevent the nuclear power plant coming up there. In Kerala, we want power only. We are not bothered whether it is nuclear or other things, as long as it happens somewhere else. Whereas if it happens here, immediately there will be a satyagraha and other things, no? So hydro is the best, but then again there is a limited source. Vellachatrams are limited. Not only that, it will submerge forests, and therefore it will cut off again the precious trees, and also displace tribals. So what is available right now is solar and wind power is the source. In fact, India's share of electricity is only 5.8% of the global, but we have pledged in the Glasgow summit that 50% of it by 2030 will be green, mostly from solar and wind. So let us take the global wind and solar installed capacities in the world from 2000 to projected 2023. Originally, it was all wind energy shown in black, and then now the solar energy has taken over. Why? Because solar was very expensive when we started. It was like this, you may not be able to see, in 1977, it costed about $76 to produce 1 watt from the photovoltaic solar cells. But today, thanks to material scientists and electronic engineers, great innovative work, today it is available for $0.3 per watt. It is available. That is why we also will go for solar. April 2021, this is our scenario. Solar or wind are 2020 each, and this is our capacity. Installed capacity is 382 gigawatt, but that we are trying to augment to 1,000 gigawatt by 2030. At that time, 50% we have promised to the world that it will be by wind and solar. If you look at wind, there is a limitation. If you look at the wind scenario, wind energy become viable only where there is a wind power density defined as watt per square meter is available above a certain value like 200 watts. It is available only in those areas where it is marked red. Plenty available near our Nagarkovil and our Mahendragiri. We have a number of plants, and this Palgad, it is there. But other places which are marked here, the wind is not sufficient or constant. That is also to have wind energy. We have installed huge wind plant in Aralvaimuli, a place called Aralvaimuli. It is this one. It is here. So our installed capacity in 2019 relative to 2020 and 23 was only equal, this much. But by 22, solar will take over wind, and by 2030 we will have. Originally we promised 450 gigawatt power from renewable sources, but now that is revised in our Glasgow meet to 500 gigawatt by solar. So India has done a lot. Probably in Kerala, because of land area not available, we are not aware. This is Kurnool Ultra Mega Solar Park in Andhra Pradesh. It covers about 24 square kilometers with a capacity to produce 100 megawatt power, much more than our, hydro we are planning, where there's a lot of controversy near Trichur. What is that place? I forgot the name. But today it is able to give electricity at 2 kilowatt per hour capacity. Okay, 2 rupees per unit. That is because of the curve we have seen earlier. But then the limitation of this power as well as the hydel power is that it has got limited locations where either land is available or waterfall is available. So unfortunately, we have a tremendous loss in transmission and distribution. So we need to reduce transmission losses. Unfortunately, it's a very, very sad plight of affair. 18% output is lost in India against a world average, including Africa, which is 8.5% only. We are lost. I think our electrical engineers and others, our politicians, everybody has to do a lot in bringing down the gap at least to 10%. Why? Because this 18% equal to 130. I always try to compare with the number of trees. Then only people will very easily understand. This is equivalent to 130 million tons of carbon dioxide emitted. Okay, that is why government is government is subsidizing grid-connected roof solar electricity, because then the losses will be minimized. Okay, shall we move on to the next? Next is decrease in human source carbon emission in transport sector. First, let us take a goods transport sector. Fuel efficiency, safety of different modes of transport is shown in this very interesting slide. Look at it very carefully. This shows truck, rail, as barge, as well as ship also. Fuel efficiency defines as distance. Of course, this type of tables are mostly generated by the American sources and it's available in open source. We don't have such one, otherwise I would have put kilometers. Fuel efficiency of how many miles it can travel with 1 ton of cargo using 1 gallon of the fuel. 59 by road, 202 by rail, and 514. That means it is in the ratio 1:3.4 to 8.8. Coupled to that, you look at the fatality ratio. That means how many fellows will die by hit by this mode of transport relatively. If 1 fellow dies here, 22 fellows dies in rail, and 151 dies in the road. And then this goes to 2000 in the case of injuries. So obviously this is the best, but however, this is very slow and therefore applicable only for non-perishables. Whereas it is ideal to have rail car in the trunk routes with short hauls by the road truck. Today, if you look at the goods transport scenario in India, we are not having again not a very good picture. Only 36% of our goods is transported by the rail, as against near 50% by USA and China. So, my dear friends, there is a need to have faster and more efficient good trains of India. Then why we are not doing? Because each kilometer of rail track costs 10 times more costly than a good road. We also need to rejuvenate our waterways, especially in Kerala. Now go to the next one, which is the passenger transport. This is again a very interesting slide. I don't have time to go to the very full detail. This shows you grams in carbon equivalent per passenger kilometer emitted by various modes of transport, starting from large motor car, the American one, big one, where it is only 15 miles per gallon, 312 gram carbon equivalent. That means almost 1. This 312 into 44 divided by 12. Chemists do not need any explanation as to why I multiply by 42 that much of carbon dioxide. Whereas look at buses and rail, that is at the lower end. This is very easily understandable because one passenger carrying capacity, one train can carry that of 10 buses and one bus can carry 10 cars, that of 10 cars. Therefore, we need more convenient public transport. This is the type of public transport today available, like what is available in Singapore. Singapore Metro is probably the best in the whole world because there is anywhere you want to go, you don't have to wait more than a couple of minutes for the train, and that is just at the exit. It is connected by a bus, and also the bus stand is connected with a number of cycle tracks available. So in Kerala, with 117 road accidents and 12 deaths daily, I repeat, every day 100. This was statistics a couple of years ago. 117 road accidents and 12 deaths daily. We need very fast trains, good connectivity. I don't want to join either the LDF or the UDF by telling you have it this way, that way, or whatever it is. That it is not my scope of my lecture. We need city bypass and roads without potholes. Earlier, people used to say that is only for carwalas. So why we were carwalas few at those days? But look at this data. 10% increase in the mileage can decrease carbon dioxide emission in Kerala by 1 million tons per year. So you get a better mileage with the road without potholes. Okay. This is a very interesting aspect in terms of the emissions of from electric car. Now there is a big fancy for electric cars. Every guy is making an electric car. But look at this particular data. If you have the electric charge, this is again US data, electric car charged from the grid electricity, coal grid electricity, then this is the emission. As against a small normal car, this is the one, only marginal increase. But really, a real advantage of electric car you will get only if you have the solar grid to charge the electric car. Okay, that is understandable. I hope so. Then look at what are the alternate fuels available to us. Why not go for other fuels? This is a very interesting slide of CO2 emissions during combustion of the fuel, coal, petrol, ethanol also included, biofuel, CNG, compressed natural gases with hydrogen. This is a table shows gram of carbon dioxide per million joule of heat generated. This is 100, this is 0. Ethanol has got only very little advantage over petrol in terms of CO2 emission, but it is bio. That is only advantage. But look at this. This while you have got advantage, there are disadvantage also. Even in liquid stage, this is having a density of 0.07 gram per centimeter cube only. Now let us look at carbon dioxide emission for the preparation of hydrogen. That is why now they talk about green hydrogen. The current method of preparing hydrogen is by steam reforming of naphtha. That is, naphtha and steam is reacted at high temperature over a catalyst to produce hydrogen and carbon dioxide. 1 ton of hydrogen produces 7.3 tons of carbon dioxide emission per ton of hydrogen produced. So it's not a good thing. So if you electrolyze water with coal grid electricity, then net emission of carbon dioxide is more than otherwise. So what is the green hydrogen? Green hydrogen is one with solar electricity or with photoelectrochemical splitting of water, where chemists, researchers can do a lot. It is going on only in the laboratory for so long. Even in my heydays in VSSC, we did some work, but still it is come to a commercial scale. So green electricity is produced by electrolysis of water with solar electricity or photoelectrochemical splitting of water, and energy through hydrogen fuel cell. Why hydrogen fuel cell? Because if you directly convert chemical energy into electrical energy, its efficiency is 70%, whereas if you go by IC engine, then mechanical to electrical, then it is low energy. Today, in fact, hydrogen energy buses are running in London. So, but then the great challenge is viable, how to handle that such low density hydrogen. Usually it is stored at about 100 to 150 atmosphere pressure cylinders. It has got its own limitation, explosion limiters, and so on. Fuel cells are to be made viable. Currently, it is a lithium-ion fuel cell which is used for running these buses. But lithium, suppose you imagine that all the buses, all the vehicles are converted into lithium-ion. Well, the entire lithium available in the earth, if you excavate, lithium will not be sufficient. So we have to go for hydrogen in time to come. So let us come to the last part of the lecture: innovative methods in industrial process to minimize greenhouse emissions. So if I take every industry, it will run to hours of discussion. So instead, I will take iron and steel industry and cement industry, because these are the relatively largest contributors. Because annual world production of steel is very huge, 1.86 billion ton. Iron is produced by reduction of iron oxide. So it currently generates in 2.6 billion ton of carbon dioxide. Similarly, cement is produced by 3.5 billion ton of cement is used now. It is produced by the decomposition of limestone, and the possible alternative are recycling of scrap iron and hydrogen steel. That is what is called green steel. That means use hydrogen for reducing instead of carbon dioxide. But technological problems are many. What is this alternate for cement? Maybe some chemists, material scientists should be able to find an answer. Next is what in this process, what is called a geosequestration of carbon dioxide. That means it's a very novel idea which is afloat but not implemented. At the power station or the industrial facility where a large amount of carbon dioxide is generated, carbon dioxide in supercritical form, you inject into deep into the earth where there is available, porous rocks are available, which is covered by impermeable rocks. So it will be kept there. Seal it here. You establish your industries at those locations where this type of terrains are available, and there's an idea. Yet another idea is, okay, there are some everybody always thinks in terms of what gain I will get out of that. If you can do it in oil producing rocks, you can produce methane, or you can produce excess oil and so on. This is one idea. Oh, sorry, this is, it's repeated in this. Okay, change in industrial process. Why not change the industrial process? The current trend is to make more money every year, roll out of a new car, new blade, and a new thing. So from linear industry, linear economy, take, make, use, and dispose of. So that generates 2 trillion tons of solid waste in 2019. 17% of it is incinerated, again leading to carbon dioxide. From these to the 3R principle of manufacturing. That means reduce, reuse, and recycle. That is zero waste design. For example, in our solid rocket motor manufacturing, we design the manufacturing in such a way that there is no waste coming out of the solid propellant while it is manufactured, because it's a hazardous, dangerous waste. So like that, in each industry, you design in such a way that there is no waste. Lifetime extension. Why not car for 10 years instead of that, like old, our German cars which used to last with equal efficiency for 20 years. Resource recovery, repair and remanufacture. Why not do that? That will reduce the emission. Another one is waste management. See, there is so much of waste. If I go each one, it will again take several hours. So I will look at one alone. For example, we produce 300 million tons of plastics. Being lighter than air, it will, lighter than water, it will clog every waterway. So we burn it. Burning not only gives carbon dioxide, but dioxin-like gases. And food waste is at another horrible waste, because there is 1.3 billion ton per year food waste is there, where 1 billion of our brethren are starving in the world over. So look at this fantastic example shown by this fantastic man. When Premier of Singapore hosted this picture, I will show in all my lectures, whether you like PM by person or not, it's a different question. When the Singapore hosted a lunch or a tiffin for Modi ji, they did it in Komal Vilas canteen with 1 or 2 idli and 1 vada. So look at this. So what I want to tell you is that moderation is the watchword for mitigation of global warming. Last is what is called the radiation management and climate engineering. Again, fantastic ideas only, not practicable. Have space mirrors. That means huge reflectors in stable orbits. So when temperature is more, reflected away. When it cools down, reflect it down. Very good idea, no? Okay, is it not? But today, look at the cost. A launch cost of 1 kilogram of a payload to a stable orbit is $25,000 per kilogram. So the entire economy put together itself, we will not be able to put solar mirrors. Another idea is to have reflective aerosol sprayed, like sulfate aerosols, or cloud seeding, so that it will be cool. But what is the impact of that on the earth? We don't know. Or have carbon dioxide capturing things like along with your streets, then either store it in the earlier I have shown you, or convert it into carbonate and then store it underground. Well, my dear friends, global warming gives you, each one of you, including me, ample scope for R&D in science, engineering, material science, and management, because it affects the entire human being, and human being is in peril. My dear friends, global warming is a reality and a threat to humankind. Its prevention is a huge challenge, especially to the developing countries. We can expect little help from developed countries who are actually responsible for global warming. In this Glasgow meet itself, our Prime Minister said, okay, we will have carbon neutral India by 2070. You tell us when your country will be carbon neutral. I don't think many others have followed his suit. Why? Because even our notorious US President, he said, I represent people of Pittsburgh, not Paris, sitting in his cool air-conditioned room with a bottle of beer. He was, I mean, this is pictorially represented, implying that they are in Porsche life they can afford to because of their income. But they have no concern for nature and future, like the first-class passengers in Titanic. They are right now in this place, but they will also sink in time to come. Why? Because carbon dioxide created in India or Africa, it will ultimately diffuse into United States also. So, my dear friends, migration can be achieved only with a collective effort by all concerned. Global warming cannot be combated by one country alone. So, India has to strike a balance between alleviation of poverty and mitigation of global warming. We have to think out of box to find out innovative solutions at affordable costs. Otherwise, our global warming will be like this. What you see in mitigation of global warming will be like this. What you see in Pathan Junction. We will not be able to do really tangible ones, for which leaders, policymakers, scientists, administrators, technologists, economists, everybody have to work together to combat global warming. We need a new model of development which is relevant to India. What is our model of development? Suppose I get a provident fund loan or a provident fund arrear or a pay commission arrear. Immediately I will buy a car because that's a symbol of our progress. But if I see this man cutting a tree, I will stone him by telling that you are cutting a tree. When a tree was cut in front of our university college, people came in car from Madras even to protest against that. But look at this scenario. This particular lady working from Nedamangad in government secretariat, it's an imaginary thing. I don't immediately say that it's a true one. She will run 9,000 kilometers a year. She will release 2,230 kilograms of carbon dioxide with a mileage of 10 kilometers per liter, which is equivalent to cutting a tree, because a tree can sequester only 220 kilograms of carbon in 100 years. Okay, so we need to have a new symbol for our progress. Not the 7 crore car owned by a sports hero, neither a 7,000 crore bungalow owned by a industrial magnate. I'm not telling that is bad, but that is not the true symbol of our progress. Our true symbol of our progress is to have a new target of a sustainable development that will make Earth livable for us and our future generation. So I propose a new slogan, like Ingulab's another slogan: sustainable development with GHG within ESL. That means greenhouse gases within the sequestration limit of the Earth. Thank you very much for your kind attention.